Okay, in this video, I will be discussing the technique of common structure variation reduction, which is discussed in this paper, Common Structure Variation Reduction in PLS-SEM, Replacement Analytic Composites, and the one-fourth rule. Um, and the model that I'm going to be using for this is here. So it is this model. So I have three latent variables in this model. And the problem, when I go to view latent variable coefficients, the problem is that one of the FCVIFs is above the threshold that I want it to be. I want it to be 3.3 or lower, and it's 3.72. Again, the threshold here is defined by the user, and in some cases, it may make sense to use a threshold that is a little bit higher, say 5, particularly if you're using factor based algorithms. Since I'm using a composite based algorithm here, I will use the threshold at 3.3. So I will want to reduce this 3.72 to a lower number. And and to do that, I will use the technique that I discussed in that paper that I showed you earlier. So first thing that I'm going to do is I'm going to change this model. Uh, Normally, what I would do is to save these changes that I would be making in another project file, uh, because I don't want to make changes here that will change the measurement model. I want to only change the structural model, which are the latent variable scores and the links among them. So first thing I'm going to do is I'm going to go to the option modify and add all latent variable scores as new standardized indicators. So now what I will do is I will go to define the model, and I will replace the indicators in each of the variables with the latent variables that were created, the latent variable scores that were created in that modify option. So I'll use uh, this here for tech. Again, I'll remove all of them. I will use the latent variable score, and I will do the same for advantage. So now I have the latent variables measured through single indicators, which are their latent variable scores. And again, the reason I'm doing this is because I don't want to change um, the latent variable scores uh, as I reduce the focal linearity variance inflation factors. And this can happen if I don't do this before. So normally, as I said, I would have saved the project file in another uh, project, and then I would save this one as my second stage model, so to speak. So I'm going to save the model and close, and I'll redo the analysis, and I should get the same FCVIFs that I had before. So I have the same. Still, this one is too high. I don't want to, and I want to reduce it. So now what I'm going to do is to create an analytic composite, which is redundant with this variable, which is the one associated with the high FCVIFs, FCVIF. I will create a redundant variable, which essentially is a variable that has a correlation with this variable that is between 0.95 and 0.99 that would be redundant with this variable. So it would essentially be a variable that has a little bit less variation in it that is shared with the other variables, but that is still redundant with this variable, meaning that it measures the same thing as this variable. In order to do that, I will go to Explore, Analytic Composites, and Instrumental Variables. I'll choose Analytic Composite. And then I will create an analytic composite based on this indicator. And I will want this analytic composite to have less variation with the other variables in the model. So in order to do that, what I will do is I will make this analytic composite to be a combination of this variable and the other two, because the other two are predictors. So I will add, I will add this one because the other two are predictors of this variable. And what I will do is I will reduce um, the influence of or the variation of those predictors in my analytic composite a little bit, um, using this one-fourth rule, which is essentially what I'll do is I'll use one-fourth of these path coefficients, and just to have them correctly uh, set up, I will open Excel and I'll calculate what one-fourth is. So one is 0.44, the other is 0.51. One-fourth of 0.44 would be 0.11, and for 0.51 it would be 0.13. And so what I'm going to do is I'm going to set the weights as these numbers, but with the inverse signs. So 0.11 for tech, and 0.13 for collab. So now I have a analytic composite that has a correlation with that latent variable ADVT that is 0.991. So it's very redundant with that particular variable. But I expect that this small reduction in variation shared with the other variables in the model will make the FCVIF for this variable to go down, and ideally go down to the point that it's below 3.3. So let's see if that happens. If that doesn't happen, I can repeat this procedure and use these same coefficients again, or I can use slightly higher coefficients here. But first, let's see if this works. Our simulation suggests that this one-fourth rule tends to work well. So I'll click on yes, I'll create a new analytic composite that will be used instead of advantage. Now I'll go back to my model. So close out of here. I'll go back to the model. I will edit this variable by removing that previous indicator and using the analytic composite that I created. I will save. I'll save the model. Now redo my analysis. And now let's see what the latent variable coefficients are. Yes, so I did reduce my focal linearity variance inflation factor. In fact, I reduced significantly. It went way lower than 3.3. Um, and prior to that, it was 3.7 something. So this concludes this demo on how to uh, perform this technique discussed in the paper called common structural variation reduction. And again, since the reduction was significant, what I could do is actually reduce a little bit those weights that I used, and maybe use start with 1/8, which is half of the 1/4, or I could just accept this, and now I don't have uh, those FCVIFs above the threshold that I want. It's since the variable is redundant, the analytic composite that I'm using is redundant with the original variable, then it should not be a problem. The results should not be very different, but I can see that I don't have that high FCVIF, which could be seen as an indication of common method bias or our multicollinearity. So this concludes this demo.